So we've dealt with the kind of the rationale. Now let's start to think about how we can go about assessing this in the context of validity and reliability. We're going to start with indirect assessments of flexibility, which are the most commonly used tools within the exercise sciences. Well, what are they? Well, indirect measures usually involve linear measurements of distance between segments, or that might be from an external object. However, let's set this in context now. These tests have been described as being practically meaningless, as they generally devolve from the combination of movements at several joints, and start positions are arbitrarily set. And you'll see why they are considered meaningless as we go through this. And the other thing to be absolutely acutely aware of is indirect methods do not assess range of motion. The one thing they don't assess is, in essence, the angular displacement around the joint. They simply assess distance, which is a very, very different parameter. And so we have to be very conscious and cognizant of the fact that they seem to have arbitrary start points. You'll see why that's so important in a moment. They seem to have multiple joints involved, and therefore multiple muscle groups involved in our one single outcome variable. So how do you know where, in essence, the range of motion, the primary contribution to the range of motion is coming from? And the fact is that their unit of measurement is not what it should be, which is degrees of articulation. So we'll start really where all these began, which is the test of minimal flexibility by Curtin, right back in the 1940s. And Curtin came up with a series of tests, actually, which were really used with the in the US, and they were used with the military as kind of medical tests with young recruits. And first test they came up with, or Curtin came up, which is what's called the floor touch test. In this case, men touch the floor with fingertips, while women must touch the floor with the palms of their hands. And can you do this? Yes or no? That was the assessment of flexibility. Now, the question you have to ask yourself is, and you can see this schematic here, or this kind of diagram here, where is the measurement? Well, there's no measurement. It's kind of very arbitrary. Can you do it? Can you not do it? So that doesn't give us anything to quantify this by. But just look at the articulations that are going on there. What are you assessing? Is it flexibility of the hip flexors? Is it flexibility at the knee? Is it flexibility in the shoulder girdle? Is it flexibility in the wrists, the elbows? Where is that flexibility actually coming from, that range of motion coming from? The other one that they came up with is what they call the trunk forward tilt, and it requires the participant to sit on a solid surface with the legs out straight, and then what they do is they measure the distance from the forehead to the surface. Now, that might sound relatively familiar to you. If you think about what they're doing, is they're sitting on the ground, they are leaning forwards as far as they can, and then you just measure that distance. So again, it's distance. We don't know which articulations are really being involved, but it might sound familiar if you think about that, picture that. And in fact, if you picture what you've got here, and if you were to simply rotate that image by 90 degrees, you'll probably recognise that it looks quite similar to what most people understand as the sit and reach test. Curtin also came up with what they called the trunk extension test. And this is where the participant is prone, and they're lying prone, they're lying on their stomach, and then it's the distance from the forehead to the surface. I'll show you an example of this. But the key thing is, none of these actually record range of motion, so there's nothing in direct degrees. Particularly the floor touch test is just arbitrary yes or no. And with the trunk tilt and the trunk extension, both of those, fundamentally, you do not know really what joints and muscle structures are involved in your single measurement of range of motion. So here we've got the kind of the modified version of the trunk tilt test. Now, the reason it's slightly modified is we are using a box on this. So you can see the participant is standing on the box. It's been modified to take out of account the thing that Curtin couldn't deal with, which was a no starting point. So there is now an actual starting point. So what they do is they stand on the box, and there is a 0 point here. And all they do is they lean forward, the legs remain straight, and they lean forward and they push this marker down, this kind of fixed ruler here. And you just measure this degree of displacement in centimetres. And that becomes your kind of indication of range of motion. Now, these two examples are the alternate. So this is with the participant in the prone position. And they can do this in a couple of different ways, but what we've got is this device. They perform the position where they're trying to keep the lower part of the body on the ground. We'll talk about the difference between these two in a moment. And they're raising the chest up, and then we slide this device in and we measure the distance between the chin and the ground. And that then gives us our measure. Now, there are a couple of things to bear in mind with this, that you can see there are different parameters here, and you think, well, is this participant in essence cheating? Because they have themselves, well, it's not cheating, because fundamentally, it's still about range of motion. They're just holding their position. So it doesn't matter that they're using their arms to hold their position. It's about how much articulation they can get around the joints. It is often recommended to hold the feet in place, because actually by holding those in place, it does mean that they get a more stable position. So they don't have to adopt this kind of position that you see here. But again, remember that what you can see is it's just a single measurement in terms of centimetres of displacement, but at no point do you really know where that articulation is coming from. So that then brings us perhaps the most commonly used test in the field of exercise sciences. Might surprise you. Sit and Reach is actually dates right the way back to 1952 from Wells and Dillion. But can you see how similar this is in terms of the position that the young man has taken here to what Cureton's test was, which was that toe touch test image that I showed you. They've just in essence added this board in, which is the standard board that most people use, to add another level of theoretical sophistication to the test. This has obviously been an amended test since its inception, and originally there was kind of a bobbing movement that was allowed. But what we in essence do is we have the participant sat. This is a fixed distance. So this distance here from this part of the box here, in all versions of the Sit and Reach top, the box is fixed. They sit with the feet flat against the box, shoes off, because again, if we have shoes on, that increases the distance away from the box. They sit with the legs out flat, and then they simply lean forward and slide the ruler or the marker down this ruler on the box. And again, what you're measuring is just a linear displacement. Again, there is no angular displacement being assessed. There's angular displacement taking place, but you're not assessing angular displacement because your metric is simply distance travelled. As I said, there was a bobbing movement that originally was allowed, but that was kind of taken out. And not surprisingly, if you think about a bobbing movement, so you bob, 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 go, in essence adds variability into the test. So it was quite sensible that that was taken out. Anything that increases variability reduces the validity of the measurement. So we've already got questions about the validity in the sense of, it's not measuring angular displacement. But we've also got that validity we talked about with the Cureton test in terms of, well, where is the flexibility coming from, the range of motion? How much of it is to do with shoulder girdle? How much of it's to do with just simply wrist range of motion? How much of it's to do with the hip flexors? How much of it's to do with at the knee? We don't really know. So there's a lot of variability issues we knew about, but at least one thing that was controlled was reducing the variability by taking the bobbing method out. However, previous authors have stated that there's good relationships to hamstring flexibility when assessed using a more direct method and to lower back flexibility. Now, what you've got to be careful of is, yes, there are relationships, but remember, correlations are not causal. So although they're correlated, it doesn't mean it is therefore a good measure of hamstring flexibility. Just because it's got a correlation of 0.7, it doesn't mean it's a good measurement of that. You have to be very careful with the notion of correlations. And you can see here kind of our setup with the box. Here's the fixed distance I was talking about. It's 23 centimetres. You can see the articulations in this example. It's quite neat actually as a schematic, because what you can see is all the joint structures that are involved in this movement, even down to the point if you've got poor articulation around the kind of the upper part of the neck, so cervical spine region going into thoracic, then it actually has an impact then on the articulation that you get around the shoulder girdle, which has an implication on the elbow and has an implication on the wrist, and so on. So it all has quite a significant knock-on effect. And at no point do you really know with this test where those articulations are coming from.